Hi everyone, I am Encapsulations, MVP in Visual Studio and Development Technologies. Today I'm going to share about loops and encapsulation. Let's start with loops. There may be a situation when you need to execute a block of code several number of times. In general, the statements are executed sequentially. The first statement in a function is executed, followed by the second, and so on. Programming language provide various control structures that allow for more complicated execution paths. A loop statement allows us to execute a statement or a group of statements multiple times, and following is the general from a loop statement in most of the programming language. C# provides following type of loop to handle looping requirements: while loop, for loop, do while loop, nested loop. Let's continue with while loop. It repeats a statement or a group of statements while a given condition is true. It tests the condition before executing the loop body. A while loop statement in the C# repeatedly executes a target statement as long as a given condition is true. The syntax of the while loop in C# is while condition then statement. Here, statement may be a single statement or a block of statements. The condition may be any expression and true is any non-zero value. The loop iterates while the condition is true. When the condition becomes false, program control passes to the line immediately following the loop. Here, key point of the while loop might not ever run when the condition is tested and the result is false. The loop body is skipped at the first statement after the while loop is executed. Let's go for a demo. When the above code is compiled and executed, it produces the following result. For loop, it executes a sequence of statements multiple times and abbreviates the code that manages the loop variable. A for loop is a control structure that allows you to efficiently write a loop that needs to execute a specific number of times. The syntax of a for loop in C# is: for init condition increment statement, Here is the flow of control in a for loop. The init step is executed first and only one. This step allows you to declare and initialize any loop control variable. You are not required to put a statement here as long as semicolon appear. Next, the condition is evaluated. If it is true, the body of the loop is executed. It is false. The body of the loop does not execute and flow of control jump to the next statement just after the for loop. After the body of the for loop execute, the flow of control jump back to the increment statement. This statement allows you to update any loop control variable. This statement can be left blank as long as semicolon appear after the condition. The condition is now evaluated again. If it is true, the loop execute and the process repeat itself. Body of loop, the increment step, and then again testing for a condition. After the condition becomes false, the for loop will terminate. Let's go for demo for loop. When the above code is compiled and executed, it produces the following result. Let's continue with do while loop. It is similar to a while statement except that it tests the condition at the end of the loop body. Do while loop, unlike for a while loop which tests the loop condition at the start of the loop, the do while loop checks its condition at the end of the loop. A do while loop is similar to a while loop except that a do while loop is guaranteed to execute at least one time. The syntax of a do while loop is do statement while condition. Notice that the condition expression appear at the end of the loop, so the statement in the loop execute once before the condition is tested. If the condition is true, the flow of control jump back up to do, and the statement in the loop execute again. This process repeat until the given condition becomes false. Let's go to do while loop demo. When the above code is compiled and executed, it produces the following result. Nested loop. You can use one or more loop inside any another while. For or do-while loop. C# allows to use one loop inside another loop. Following section show few examples to illustrate the concept. The syntax for a nested for loop statement in C# is as follows. The syntax for a nested while loop statement in C# is as follows. And nested do while loop statement in C#. A final note on loop nesting is that you can put any type of loop inside of any other type of loop. For example, a for loop can be inside while loop or vice versa. Let's go for demo of nested loop. The following program uses a nested for loop to find the prime number from 2 to 100. When the above code is compiled and executed, it produces the following result. Let us to continue with loop control statement. Loop control statement. Loop control statement change execution from its normal sequence. When execution leaves a scope, all automatic objects that were created in the scope are destroyed. C# provide the following statement: break statement, continue statement. Let's start with break statement. Terminate the loop or switch statement and transfer execution to the statement immediately following the loop or switch. The break statement in C# has following two usages. When the break statement is encountered inside a loop, the loop is immediately terminated and program control resumed at the next statement following the loop. It can be used to terminate a case in the switch statement. If you are using nested loop, one loop inside another loop, the break statement will stop the execution of the innermost loop and start executing the next line of code after the block. The syntax of a break statement in C# is as follows. Let's go for a break statement demo. When the above code is compiled and executed, it produces the following result. Continue statement causes the loop to skip the remainder of its body and immediately retest its condition prior to reiterating. The continue statement in C# works somewhat like the break statement. Instead of forcing termination, however, continue forces the next iteration of the loop to take place. Skip any code in between. For the for loop, continue statement causes the conditional, test, and increment portion of the loop to execute. For the while and do while loop, continue statement causes the program control passes to the conditional test. The syntax of a continue statement in C# is as follows. Let's go for the continue statement demo. When the above code is compiled and executed, it produces the following result. Infinite loop. A loop becomes infinite loop if a condition never becomes false. The for loop is traditionally used for this purpose, since none of the three expressions that form the for loop are required. You can make an endless loop by leaving the conditional expression empty. Let's continue with second of the topic, encapsulation. Encapsulation is defined as the process of enclosing one or more items within a physical or logical package. Encapsulation in object-oriented programming methodology prevents access to implement details. Abstraction and encapsulation are related features in object-oriented programming. Abstraction allows making relevant information visible, and encapsulation enables a programmer to implement the desired level of abstraction. Encapsulation is implemented by using access specifier, and access specifier define the scope and visibility of class member. C# support the following access specifiers: public, private, protected, internal, protected internal. Let's talk about public access specifier. Public access specifier allow a class to export its member variable and member function to other functions and objects. Any public member can be accessed from outside the class. Let's go for demo of public access specifier. The following example illustrates this. When the above code is compiled and executed, it produces the following result. In the preceding example, the member variable length and width are declared public, so they can be accessed from the function main using an instance of the rectangle class named R. The member function display and get area can also access the variable directly without using any instance of the class. The member function display is also declared public, so it can be also accessed from main using instance of the rectangle class named R. Private access specifier. Private access specifier allows a class to hide its member variables and member function from other functions and objects. Only function of the same class can access its private member. Even an instance of a class cannot access its private member. Let's go for demo private access specifier. The following example illustrates this. In the preceding example, the member variables length and width are declared private, so they cannot be accessed from the function main. The member function accept detail and display can access this variable. Since the member function accept detail and display are declared public, they can be accessed from main using instance of the rectangle class named R. Protected access specifier. Protected access specifier allows a child class to access the member variables and member function of a base class. This way is helped in implementing inheritance. Internal access specifier allow a class to export its member variable and member function to the other function and object in the current assembly. In other words, any member with internal access specified can be accessed from any class or method defined within the application in which the member is defined. Let's go for internal access specified demo. The following program illustrates this. And you will get a result length equal to 4.5, width equal to 3.5, area equal to 15.75. In the preceding example, notice that the member of function cat area is not declared with any access specified. Then what would be the default access specifier of a class member if we don't mention any? It is private. Protected internal access specified. The protected internal access specified allow a class to hide its member variables and member function from other class, object and function except a child class within the same application. This also used while implementing inheritance. Thank you. That's all for my presentation.